Hello, today we're going to look at measures of central tendency. So any measure of central tendency, which is just a measure of the middle, is called an average. We're going to study 3 of them here. They are called the mean, median, and mode. So we're going to start with the mean, and that's probably what you think of when you hear the word average. But again, any measure of central tendency is considered an average. But the mean is either denoted by x bar or by the Greek letter mu, and it really technically depends on if it's the average of everything or the average of a sample, but we're just going to use x bar just to simplify things. So in this formula, n is the number of values in the data set. And then each xi, for I being 1 through n, represents a value in the data set. So the first number in the data set would be x1, the second value x2, the third value x3, and so forth. And then this Greek letter sigma here, capital sigma, means the sum. So S for sigma, S for sum. So the symbol means that we're going to sum the values x1 through xn. Right, so the subscript here in the bottom is where we're starting at 1, and then n at the top here is where we end. So we're adding up the values x1, x2, all the way to xn. So find the mean of each data set. So 4, 7, 2, 2. So we're going to add up those values. So x1 through x4. So 4, 7, 2, and 2. We add them up, divide by 4. So we get 15 over 4. So the mean is 3.75. And you always want to check, does that make sense? So again, it's a measure of center, a measure of the middle. So does it make sense that 3.75 could represent the middle of these values? And yeah, we've got 2 values that are below it and 2 values that are above it. So hopefully that seems reasonable. How about 10, 20, 35, 25, 60, and 0? So we're going to add up all those values, divide by n, how many values we have, which is 6. It's going to give us 150, and then we divide it by 6, so we get 25. And again, we ask ourselves, does it seem reasonable that 25 could be a measure of the center? And again, hopefully it does sound reasonable. We have 2 values that are above it, 3 values below it, and 1 equal to it. So it is somewhere in the middle. And then 120, 24, and 560. So we want to add them up, divide by how many values we have, which is 3. We get 920 over 3, which gives us 306 and 2/3, or 306.6 repeating. The next average is the median, and that is the middle value of the data set when the data is written in numerical order. So you need to make sure that it's in order before you find the middle. Otherwise, the median could change depending on how you reorder the data set, but the data set would still be the same. So there's exactly 1 median, so we're going to look at the data set in order. Now, if n, remember the number of values is odd, then there is a middle value, right? If you have 3 kids, there is a middle child, and it's located in the n plus 1 over 2th position. So if n is odd, n plus 1 is even, so I can divide it by 2 and I get a number. So again, if there are, say, 3 values, then the middle value is in the 3 plus 1 over 2, which is 2nd position. If n is even, then there is no middle value, right? If you have 4 kids, there's no middle child. And what we do is we take the mean of the 2 middle values. So if you have 4 items, 4 data sets in numerical order, then the 2 middle would be the 2nd and 3rd data set points, and we would find the mean of those 2. And when you find the mean of 2 numbers, it's the same as the midpoint. We have a symbol for the median, which is x tilde. So let's do some examples. So find the median of each data set. So 2, 7, 2, 4. So in order to find the median, we need to put them in numerical order. Whether it's descending or ascending doesn't matter, just they have to be in order. So 2, 2, 4, 7 or 7, 4, 2, 2. And then if we notice, there are two middle numbers here because n is 4. So we're going to find the midpoint of the two middle numbers. The midpoint of 2 and 4 is 3. Again, we can consider it to be the mean of 2 and 4, which is 2 plus 4, or 6, over 2, which is 3. And we got 120, 480, and 225. So the first thing we're going to do is put them in order. So 120, 225, 480. And then with three numbers, there is a middle. So the median is 225. And we got 10, 20, 35, 25, 60, and 0. So we're going to put them in order. And then we have 2, 4, 6 data values. So n is even, so there is no middle. So we're going to look at the middle two, which are 20 and 25. And we're going to find the midpoint of those two, which is 22.5. Next is the mode. So the mode, which doesn't have a universal symbol, is the value of the data set that appears the most. This is the only measure of center that can have 0, 1, 2, or more answers. So every data set has one mean and one median, but you might have no mode. You could have one mode, you could have two modes, you could have 12 modes. So it's the only one where you don't necessarily just have one answer. So if the data set has no mode, that means that all the values appear the same number of times. One mode, we call the data set unimodal, is if the data set has one value that appears more than any other value. We could have two modes, where the data set is called bimodal, and that is a data set where two values appear more than any other value, and those two values appear with the same frequency. So the frequency is just how many times it appears. We could have three modes, called trimodal. That's a data set where three values appear more than any other value, and again, they appear with the same frequency, or they appear the same number of times. And then that can continue, 4 modes, 5 modes, 12 modes, 100 modes. However, the mode is used to pull out what values are important in the data set. And then depending on the use, some statisticians decide that having 3 or more important values is no longer important. So sometimes we consider them to have no mode if they have 3 or more modes. And it really just depends on who you're talking to. So, if you're talking to someone where having 6 modes is still important, then you could have up to, at that point, 6 modes. Okay, but some people, again, think that if there's more than 2, then it's no longer really important, so we consider it to be no mode. So let's find the mode for each data set. So our first data set, 3, 2, 1, 2, 4, 2, 3. Now, just like with the median, it makes sense to put this in order, and then we can collect all of the 1s, all of the 2s, all of the 3s, and so forth, and it's easier to find the mode that way. So we're going to rearrange them in order. So 1, 2, 2, 2, 3, 3, 4, and we can see that we have 3 2s, and no other data set appears more than that. So our mode is 2. So this is a unimodal set. There's one mode, and that mode is 2. Next, we have 10, 15, 30, 15, 20, 10, 25. So I'll put them in order. And then we'll hopefully notice that we have 2 10s, 2 15s, and no other data set appears more than once. So this data set is bimodal, and there are 2 modes. So the modes are 10 and 15. And then we have the following. And again, we're going to put them in order. When you rearrange them and put them in order, it's really important to make sure you don't miss any. So when you do it, you always want to check how many values do you have before you rearranged it and how many values do you have after you've rearranged it, and make sure it's the same number. So when we're doing this, we want to double check that we have, say, 2, 4, 6, 8 numbers to begin with, and we have 2, 4, 6, 8 numbers after we've rearranged them. And then if we notice in this data set, every number appears twice, so that means there's no mode. They all appear the same number of times. Let's find the mean, median, and mode for the following data sets. So we have 8, 12, 10, 10, and 6. So again, the first thing I'm going to do is put them in order because I want to do that for both the mean and the mode. The median and the mode, I mean. The mean, I'm going to add up the numbers. If I add up those numbers, I get 46. And I'm going to divide by 5 because that's how many numbers we have. And that gives us a mean of 9.2. And again, hopefully that makes sense. If I were to add that to my data set, it would end up here, which is in the middle. The median, is 10. There are 5 values, and this 10 here is in the middle spot. So our median is 10. And then for the mode, we have 2 values of 10. So the mode is also 10. And then for our last data set, we have the following: 200, 225, 250, 250, 225, and 0. So we're going to put them in order, and then we're going to find their values. So the mean, we're going to add them all up, and we get 1150, divide by 6, and that gives us 191 2/3. Now, if I just placed that in our list, it would go here, and that might not seem like it's the middle because there's only 1 below it and there are 5 above it. But we have a problem with that first value of 0. 0 is very different from the other 5 values. It's a lot less than the next value, 200, and that's what we call an outlier. And what we're going to see in a minute is that outliers vastly skew the mean. So as I said, our mean here is 191 2/3, which is a lot lower than most of our values. Not a lot lower, but lower than most of our values. Okay, like I said, it's only bigger than one of them. So we're going to see how this affects our measures of center if we have an outlier. So we'll check next with the median. So we've got 6 values, So there is no middle value. So we look at our 2 middle, and we're going to take the average, or the mean rather, or again, the midpoint of those 2 numbers. So since those 2 numbers are the same, the midpoint is 225. So the median is 225. And then for the mode, we're going to notice that these 2 numbers both occur twice. No other number occurs more than once. So we have 2 modes, 225 and 250. And again, this data set would be considered bimodal. So we want to see what happens if I get rid of the outlier. So what if we pretend that number's not there? How does that affect our measures of center? So our median, notice, would be the same. Of those 5 values, our middle value is now exactly 225. There is a middle value, and it's 225. So our median didn't change. What about our mode? Our mode also didn't change. We still have 2 225s and 2 250s, and at most 1 of any other number. So our median and our mode stay exactly the same. So if we have an outlier in our data set, it doesn't really affect the median or the mode at all. It definitely doesn't affect the mode if it's an outlier. There's only 1 of them. And then the median could be slightly affected by just moving to the next value over, But in this case, we notice it doesn't change at all. But as I said before, it does really change the mean. So if I redo the mean with these 5 values, then the sum is still 1150 because I'm just not adding the 0, which didn't add to the sum. But now n is only 5. So that brings my mean up to 230. And that looks more like a measure of center of those 5 values, right? 230 would be right in here. So it does change the mean quite a bit. It jumped up almost 40, by 40. So it changes the mean a lot, but it doesn't change the median or the mode. Okay. So sometimes, depending on what you're finding the measures of center of, you might need to get rid of outliers if they're skewing the data a lot. So that's something to keep in mind. Let me know if you have any questions. Thanks.